guys, and welcome back. Today we're going to be talking about Punnett Squares. So what on earth is a Punnett Square and why do you use it? Well, a Punnett Square is what we have behind us right here. Well, why are you using this? What's with these random letters? Okay, so let's talk about the question, why do we use it first? So we have two parents, both of which have brown eyes. Well, what are their children going to look like, right? And so there's a couple of ideas that you need to understand here before what you're getting from a Punnett square makes sense. So you get a dominant gene, and so a dominant gene is usually, we show this with a capital letter, a big letter, right? So in this case, the letter B. And so this is the bossy gene. If you have one copy of this gene, that's what you got, right? So in this case, you're going to have brown eyes. Why? Because you have a brown-eyed gene. In the other case over here, you have one blue-eyed gene, right? And so this is a recessive gene. You have to have two copies of that blue-eyed gene in order to have blue eyes, right? So both of these people are carrying a blue-eyed gene, but they don't have blue eyes. Why? Because they have that one bossy brown-eyed gene. All right. Now, there's another word to explain what's going on here, right? So when you do not have just one form of a gene, that is called heterozygous, right? Your parents disagreed what color your eyes should be, or how tall you should be, or whatever, right? Another example would be, and it doesn't just have to be the letter B. It could be the letter A. It could be the letter S, or whatever, right? So usually they're using some sort of letter that kind of gives you a hint as to what's going on with that gene. Now, if the two letters agreed, so I had little a, that'd be homozygous. Or if I had big A, that would be homozygous, right? And this little a, the homozygous recessive. Big A, the homozygous dominant. And so what this box is supposed to show is you put one parent up top and another parent on the side. Some places like to make a big deal as to what parents up top and on the side. Realistically, it doesn't matter. You're going to have the exact same outcome, whether you put mom on top or mom on the side, dad on top or dad on the side, right? It really doesn't matter. So what they're trying to show is that when you go to produce children, half the time you're going to give one gene, and half the time you're going to give the other gene, right? And so we'll just look at parent number one right here. And so half the time he's going to give his big brown-eyed gene right here. The other half the time, he is going to give his blue-eyed gene. All right? And so half of his children will have received a brown-eyed gene from him, right? Because we have 1, 2, 3, 4 children, but two of them have his brown-eyed gene right here. Now, what about the other parent? So parent number 2. Well, when they have children, they're going to do the same thing, right? Half the time they'll give one gene, half the time they'll give the other gene, right? And so we're just going to follow this across right here. And so these children all receive parent number 2 brown-eyed gene right here. All right. Next thing we got is these children right here all received mom's blue-eyed gene. And so now what's going on here? What do these results tell us? Well, 1 out of 4 of their children are going to be homozygous for brown eyes, right? But 3 out of 4 of their children are going to have brown eyes. Why? Because 2 out of 4 are going to be carriers of the blue-eyed gene. They're going to be heterozygous for blue eyes. Now, it doesn't matter if the blue-eyed gene comes first or if it comes second, they still got brown eyes. Why? Because that brown-eyed gene is dominant. It says, no, I'm in charge. We're going to have brown eyes. All right. Next thing we got right here is this is their one child that has blue eyes. Why? Because both mom and dad gave their blue-eyed gene when they had that child. And so that's all the Punnett square is trying to show you, is how, what you would expect in terms of children, right? On average, 1 out of 4 of these children would have blue eyes, all right? Now, if we change kind of what's going in here, we'll just say that this parent right here is homozygous for the brown-eyed gene. Well, guess what? They're not going to have any blue-eyed children, right? If mom or this other parent is homozygous for the blue-eyed gene, well, guess what? All their children will carry that blue-eyed gene right there, right? But none of them will have blue eyes. And so, yeah, that's all this thing is trying to show you there. Well, let me know if you guys need any more examples.
All right, that concludes today's episode. If you liked what you heard, be sure to click the subscribe and like button down below. And as always, if you have any questions, comments, concerns, or if there's any particular topic you'd like me to create a video on, let me know in the comments down below. All right, well, I look forward to seeing you on my next podcast.